Hey guys, welcome back to Michelle's version of calculus. We're doing 7.2 verifying solutions. This is kind of a review. There are two different types of solutions that we learned in Unit 6 when it came to integrating, and that was particular solutions and general solutions. Particular solutions are solutions that they didn't have plus c written in them, and they actually had the numerical value in place for the plus c or the constant when we integrated it, and the plus c's had to be found. General solution to this equation, are the solutions that have the plus c involved. So let's say we had like 3x plus c, that's what that would look like. And then over here, it would be like 3x plus 6. That value right here would be different. And so in 7.2, we're going to be basically verifying solutions, and another thing to know is that the derivatives can be used to verify that a function is a solution to a given differential equation. And you'll see that kind of in the end. I'll show you guys how that works. So right here we have dy dx equals 8 cosine of 4x, and we have our 2 points here. These 2 points are acting as our x and y. Excuse me. These 2 points are acting as our x and y, of course, and they're asking us to find the particular solution. So remember, we're actually going to be finding and solving for c, which is why they gave us these points here. So we're going to go ahead and solve this. So in order to find a particular solution, we know the particular solution is going to be looking like y equals something x plus some constant. And as you can see here, they gave us dy dx, Leibniz notation for first derivative. And this is where integration and derivatives is important for you to really understand how they work. In order to go back and get the y equals equations here, we are going to basically integrate this here. So, I know, my hand's kind of blocking it, sorry. We're going to be integrating 8 cosine 4x. And that's nothing too crazy, pretty simple. As you can see here, this 4x inside of parentheses, because if you would use what's called chain rule when you're deriving it, when you're integrating it, you're going to be using u sub. So this is a u sub question. So our u, remember, is always going to be your inside function for u. So u equals 4x. We are going to derive u dx. That is going to be equal to 4. And then once we rearrange all of this puppy, it's going to be du over 4 equals dx. Oh, that's what's missing. I apologize. Forgot the dx in our integration. That's what we're about to plug in right now. So then now we're going to get y equals integration of 8 cosine u, remember, u sub for a reason, of d. I apologize, that's not right. Of du over 4. Perfect. Alright, so then after that, we're actually going to go ahead and just integrate this out. Remember that when we're doing this, this 8, this is basically a 1 over 4 here. We'll deal with this. Sorry, let me get a highlighter out. We're going to deal with these puppies first. So this 8 and this 4, they're basically going to come out because they're both constants. So that's going to turn into 2, and then derivative, I apologize, integration of that, of du. Alright, and so now we're just going to go ahead and antiderive this. This should just be memorized. Antiderivative of cosine is going to be sine. So then now we have 2 sine of u du. And then we kind of just finished solving this out. 2 sine, we plug in our 4x back in here. So 2 sine 4x. And then we're going to add our plus c. Because remember, right now we are technically making a general equation that we're going to solve for c in a bit. So here's our general equation right here. And now to solve for c, we're using the points that they had given us ever so graciously. And we're just going to plug them in. So this is going to be negative 2 equals 2 sine. which form right? Pi over 2. Pi over 2. And of course, we're keeping this plus c for now because we're about to solve for it. So then this turns into negative 2 equals 2. The sine of pi over 2, remember we're just doing our unit circle here, is just, remember that pi over 2 would be right here on our unit circle. And the point here is going to be 0, 1. So our sine there, the sine's y basically, our sine is going to be 1, so 2 times 1 plus c. So negative 2 equals 2 plus c. Once we do some basic algebra, we get that c equals negative 4. Yay, c equals negative 4. And we're quite literally just going to rewrite the equation that we ended with here. Our general solution, so I'm writing this down. And we're going to make it a particular one just by plugging in the plus c. I apologize for a lot of errors, but our final answer is going to be y equals 2 sine 4x minus 4. Yep, and this is our final answer on finding our particular solution. Another thing I want us to know is that sometimes when these differential equations, they're going to want to... Oh, I apologize. There you go, that's what I did. They're going to want us to solve for c. So that's something else to keep in mind and keep note of. So yeah, that, or not C, I apologize, solve for K. We're going to want to solve for a constant. Alright, yeah, that's it. Thank you, thank you.